Okay, now we're in 3.2, where we're going to start talking about loops in Java. So let's get after it. Okay, 3.2 loops. Now, if you're coming from JavaScript, you already understand loops. If you're new to Java and new to any programming language, I'll break it down to you. So let's follow along in the curriculum. 3.2 loops. 3.2.1 for loop. In Java, we write a definite loop, aka a for loop, as, here we go, public static void main string, and we have our brackets of arrays that represents arrays and our args. Now inside the block of code, we have this for loop, and it's similar to in JavaScript, but different because this is statically typed, because we have to go ahead and declare the type from the beginning. So here, what it reads is we have the int, which that's what I is going to be. It has to be a number, and we initialize it at 0. And then we iterate over that I less than 10, and then we increment by 1. And here we have our system.out.println I. It's going to print on each line. And there it is, 0 to 1 or 0 to 9. Now, if we would have put an equal sign after the less than sign, it would have print the 10. That's what the greater or less than equal represents here. It prints the actual digit or whatever it is inside of the loop all the way up to that number. So it includes the number that you specify. Now, note, you may not be familiar with the expression I++, since it is not found in all languages, which it is found in JavaScript. The plus is an increment operator that has the same effect as I plus equal 1. In this example, since the plus comes after I, we call it a postfix increment operator. There is also a dash, which means negative operator or decrement operator in Java. For more information, see the increment and decrement operators. I encourage you to go to that documentation and go over it. Get familiar with it if you don't already understand it. If you're coming from JavaScript, you may already understand it. So again, this may be review for you. The Java for loop gives you explicit control over the starting, stopping, and stepping of the loop variables inside the parentheses. You can think of it this way. This is the syntax for start clause, stop clause, step clause. And then we have our statements. Now, if you want to start at 100, stop at 0, and count backwards by 5, the loop is written as like this. We have initializing the I as an int, knowing that it's going to be a number. And this I is a variable, and a variable is a container. If you're new to programming, that a variable is a container. That's all I is holding the results. And then we, instead of initializing it at 0, we initialize it at 100. Now notice the difference. Now, if I is greater than 0 or equal to 0, then now this is where we do I negative equal 5. So it's going to take away, count down by 5s. And here's the output, or part of it anyway. And you can just imagine it all the way down to 0. Now, 3.2.2, the for each loop. Java also provides a syntax to iterate over any sequence or collection, such as an array. Pay attention to this syntax, it's very important. Here we got the public static void main string, and we're passing in an array. We know that this is the parameter right here. If you're new to programming, this is the parameter, and we'll explain more as we go forward. Here we have an int nums. We initialize num variable as it only can take in numbers, because remember, Java is strongly typed. So whatever you declare a variable, whatever data type you give it, you cannot change it. You can't mismatch it. It has to be that particular type. And here we give numbers. We have 1, 2, 3, 5, 8, 13, and 21. And we want to loop over that with the for each. Now look at the syntax here. Notice in the for each, we still declare our I variable as an int or an integer. And notice the colon right here, not semicolon, but the colon and the num. This is how to identify a for each loop. When you see that, think like the compiler. This is a for each loop. Always look for the clues when you're learning programming languages and pay attention to the patterns. Understand the rules and the principles. And then we're going to system out print line I. Now here, the loop variable moves through the items in the array of integers dot nums, or integer, the nums array. The syntax here uses a colon symbol. This type of loop is known as a for each loop. Tip: when considering this structure, it can be helpful to read the code sample above to yourself as for each integer in array nums. So that's how you want to read it. Tell yourself, for each integer in array nums. This is an integer because we have declared it an integer. This loop version also works with a string, where we can convert the string to an array of characters. See, we have the message string. We're declaring it as a string. We're passing in a string, hello world. And then we are looping over it. Notice the data type, char C. The variable is C. And message to char array. This is a method. And then system output C. Now, as you can see, to iterate through a string, in this way, Java requires an extra string method to char array to convert the string to an array of characters. If you're coming from JavaScript, think of it like this, like the split. You're splitting on a delimiter. So you're splitting on whatever in between every letter or every word, or if there's a dash inside of the string, you're splitting on that. You're splitting it to break it down into individual characters in an array. That's how we convert strings in JavaScript. Here in Java, you have this method, which is called toCharArray. Now, 3.2.3, the while loop. Here we're establishing or declaring and initializing I to be 0. While I is less than 3, we iterate over it, and then we do the I++. We increment over it until we get to 0. So it goes, is I less than 3? If that's true, it prints 0. Is 1 now less than 3? Then it'll print that. It'll store that in I. Is 2 less than 3? Then it'll store that in I if that's true. Is 3 less than 3? Then it's like, yes, it's less than 3. No, it's not less than 3. It's equal to 3. So it's just going to print to the 2. And then unless we put less than equal to 3, it won't include the 3. Make sure you play around with this to better so you can visualize it. So here we have 3.2.4, the do while loop. Java adds an additional, if seldom used, variation of the while loop called the do while loop. The do while loops is very similar to the while loop, except that the condition is evaluated at the end of the loop rather than the beginning. This ensures that a loop will be executed at least one time. Some programmers prefer this loop in some situations because it avoids an additional assignment prior to the loop. So here we have the do while here, and we're putting the false at the end of the condition. So it's the condition is right here. Now, I rarely ever use a do while loop. I don't ever think I used a do while loop, but it's good to know what it does. So you may want to practice because there are use cases for using a do while loop. But I just wanted to put that out there. Now, above the message prints despite the condition never being met. So we have hello world. So it prints hello world while false. So if that's false, it's supposed to not do anything. And so that's why I'm gonna be honest with you. I've never used the do while loop, but again, it's good to understand what it does. So 3.2.5, break statements in loops. There are instances where you may want to terminate a loop if a given condition is met. In these instances, the break statement comes in handy. For example, say you want to loop through an array of integers to search for a given value. Once that number is found, you want to quit the loop. You can do the following. Now let's look at this here. We have an integer array. So we know we're going to store inside these numbers in an array. And notice again, we're using curly brackets when we're building an array. So here we know that these numbers are stored inside this int array, and this is the variable sum ints that has the array in it. Now I have a search term 10. So now when I loop, I'm looping over one int, and then I want to get some ints. I want to get whatever inside, loop over this particular array and pull out those individual items. But then I want to check. So I'm running a check here, my condition. I'm comparing something. So this is what we're calling a check. I'm checking to see if one int is equal to search term. Search term is 10. As my for each loop goes through each one of the items, soon as one int is equal to 10, it's going to print this found it. And then it's going to break and stop. So think of the break like a return, and it hits that return, it's done. And it comes out of the loop. Now, in the code above, instead of the for loop iterating through all the integers in the array, it will stop after it finds the first matching instance. So once it finds that first 10 in the array, it prints found it and then terminates the loop. If the break statement weren't there, the loop will continue, and when it found the second 10, it would print found it a second time. Note that the break statement terminates the innermost loop that it is contained within. So if you have nested loops and use a break statement within the innermost loop, then it will only terminate the loop and not the outer one. If a break is present in the outer loop, it and any other block nested within it, it terminates when the break runs. So notice the difference here. You have a for loop and you have a nested for loop. And what's in the innermost, if you have a break on the innermost, it stops there. But now what this is saying here, so if you have nested loops and use a break statement within the innermost loop, then it will only terminate that loop and not the outer one. If a break is present in the outer loop, it and any other block nested within it is terminated when the break runs. So if the break is at the top one or the first for loop, and once it goes through that one time, it stops and it terminates all of them. But if you only have a break and you have a for loop nested within a for loop and you have the break nested in the nested for loop, it only stops that one, but the outer one will keep going. Hopefully that makes sense. And again, play around with it to make sure you understand. Now in 3.2.6, continual statements in loops. The continue statement is similar to, but importantly different from the break statement. Like break, it interrupts the normal flow of control of the loop. But unlike break, the continue statement only terminates the current iteration of the loop. What does that mean? It's going to go to the end of the loop. It won't stop once it finds what it's looking for. It just goes to the end. So we're going to see we'll look at this example here. So here we go. So the loop will continue to run from the top as long as the Boolean expression that controls the loop is still true. After continue statement, here is the example. So look at our example here, similar to the other one, right? Because we have the continue, here's the output. So the first zero index 0 is 1. It's not 10, so it's not here. But index 1 is 10. It says found it. But it won't stop there like a break. A break would stop there and it terminates the loop. But because it says continue, it goes until it gets to the end. And just so happened there's another 10. And so it says found it. But now look at this. Because of the continue statement, the final print statement in the loop is skipped. The final print statement. So it does loop one more time, but it stops after it found what it was looking for. If the continue statement weren't there, the output will look like this instead. So if I didn't have a continue here or a break or anything, it would loop through everything and it give me every time it looped. And that last one not here would have been printed. So here's your references. Take the time to go through these references and then check your understanding. Now we made it to the end of this section. Go ahead and go back over the curriculum again. Go back over these chapters. Make sure you understand it. One of my advice to you is that I will go through all of these, the whole chapter first, and then go back and study each part again. Don't get stuck not knowing what's in the curriculum, because we may be able to answer something that maybe puzzle you or perplex you later on in the section. So my advice is go through the whole section, the whole chapter, and then come back and go over it again step by step. Okay, so now the more you practice, the more you improve. I'll see you in the next video.